All right, welcome guys to this um, review for chapter 6, and I want to concentrate on a couple of things here in chapter 6 that I consider kind of important. So, chapter 6 is about synchronization tools, right? And if we want to take a look at the chapter 6 here, we talk about a bunch of things, particularly the background, the critical section problem, Peterson's solutions, mutex logs, hardware sports, semaphores, monitors, and liveness, right? So there are a couple of things here that is more in theory, so it's good to read. And the others are, you need to understand how the algorithm works, right? So read a bit about background so that you understand where we are, you know. And one of the things that I feel is important is the race conditions, right? So you want to find out actually what constitute to a race conditions, right? When is it a race condition occur, right? So we know that processes can create child process of itself, and these are some of the issues when you have multiple process running, right? And it can cause some of who will have access to a particular variable at a given time, for example, right? So when we have race condition, we have something as well called critical section problems, right? So there are sections of the code that requires only one person to access it at a given time, and this code is what we call the critical section, right? So we consider that each process has a critical section in this case, and it's just a segment of code there, right? So so who gets to access the critical section is a problem for multiple processes described here, right? So if we look into this, so there's always some kind of code. There's an entry section and an exit section and a critical section right here, right? So within this section, we say that only one process is allowed to enter this, right? And it doesn't really matter about the other sections of the coding, right? Now, so whenever the requirements for having a critical section, right, basically would, create three items here, right? Three things here that you have to understand: the mutual exclusion, progress, and the bounded waiting, right? So these are three terms that are important for the critical section, right? So what is mutual exclusion? You have to know that, right? So basically, it says that if one process is executing in the critical section, then no other process can be executing, right? So we only allow one process, then that is mutual exclusion. The second thing is progress, right? If no process is executing in its critical section and there exists some process that wish to enter the critical section, then the process will enter the critical section, right? Uh, and cannot be postponed indefinitely. So, in this sense, if what it means, if there's a process that wants to enter the critical section, right, and there's no other, no one else is in the critical section, then it is allowed to enter the critical section, right? And then there's the bounded waiting, right? So there must be a bound of how long you can be in the critical section in this case. Uh, so there are many ways to implement this. We have the interrupt-based solution, right? So please read about this and understand how it works, right? So the interrupt-based solution is basically there's two things about it. One is the software solution, right? So we use some kind of a software approach in dealing with this, where we have a variable here that keeps on turning, right? And then before you can enter the critical sections for each process, right? For each process I, right? So think about this algorithm for a bit and understand how it works, right? uh, And there's also the Peterson solution, right? So the Peterson solution is kind of familiar. We have a flag and we have a turn, and if the flag and the turn for the process is true, then they can be allowed to enter the critical section in this case, right? So this is one of Peterson's solution. So you might want to know the difference between these two. So when we're looking at whether the algorithm works or not, we consider the correctness of the software solution. We look at the mutual exclusion, we look at the progress, and we look at the bounded weighting requirements, right? If these are all satisfied, then this is true, right? Then we say the algorithm is correct, right? It's the same thing with the Peterson solution, right? So we have mutual exclusion, we have progress and bounded weighting, right? So it's important to understand whatever the solution is, how is it that we analyze whether the solution will satisfy mutual exclusion, progress, and bounded weighting, right? So in modern architectures, basically, uh, there's some examples of the using this in modern implementation, right? uh, so in modern architecture we use a memory barrier. This is basically using the computer memory, right? And there's some examples about this. Read about it. There are some hardware instructions that supports this, right? um, and please read about it, and some compare and swap solutions, right? So these are all in the hardware solution. One other thing that I would like to also put note is the atomic variable, right? So most of uh, you know um, you know atomic variable basically provides a atomic, we call it uninterruptible updates on basic data types such as integers or boolean, right? So meaning that once it's inside it, right, there's no way to interrupt it in any way when we're in an atomic variable, right? And this kind of help make sure that mutual exclusion is enforced. Okay. So other methods are using mutex locks, that actually helps make things easier. Similarly, before you enter, you acquire a lock, and then you release the lock when you get out. So anybody else who wants to enter will require the lock, right? And this concept is similar to what we call a semaphore. It's being used in programming languages, and basically to implement some of the critical section that you want to implement, right? So please read about this, right? Understand the types of semaphore that can be used, right? And how semaphore is being used, right? So there's also a few methods of using the semaphore. One is the busy wait, no busy wait. There is the using the monitor, right? There are some problems as well. Find out what the problems are, right? When using semaphore, right? And the use of using a monitor, right? So in semaphores, right, to implement the critical sections, right? All right. So understand the concepts, because the concepts are kind of important for and the last thing that I would like to concentrate on is liveness, right? So make sure you know these topics well. What is liveness, right? So liveness refers to a set of properties that a system must satisfy to ensure processes makes progress. So here, right? Make sure that you get this progress, right? Uh, So if someone is indefinitely waiting, then it has failed liveness, right? So there's no liveness there, right? So make sure you tend to think about whether algorithms have liveness in it or not, right? So if a process do not have liveness, right, there's a possibility that they might end up with a deadlock, right? So a deadlock is where two or more processes are waiting indefinitely on an event that can be caused by one or only one of the waiting processes, right? So understand how these two processes here can be in a deadlock, right? So this guy is waiting for him, but at the same time, this guy is waiting for him, right? So they're waiting on each other, right? But it could be in such a way that, you know, a set of processes are waiting for another set of processes, right? That can cause a deadlock, right? So when we don't have liveness, it's possible that we can have a deadlock occurring, right? And because, you know, you can imagine your code could be complex, you know, where, you know, you require uh, wait and signal everywhere that's happening using semaphore, and it's really hard to figure out actually what is causing the deadlock, right? And the next thing is starvation. Understand this concept, right? This is indefinite blocking, right? So what it means is a process may never be removed from the semaphore queue in which it is suspended, right? So, you know, I want to enter a critical section. I am in the queue somehow to access it, but somehow I will never get to it, right? I never get to run or enter the critical section. And this actually causes some kind of starvation, right? So, you know, so find out about this as well. These are some of the terms that are considered important and will be appearing somewhat in your test one, right? So make sure you study. When you study and you look at the slides, make sure you concentrate on these topics, right? All right. So that's about it in chapter 6. So, you know, when you watch the video and read the slides, make sure you keep what we mentioned earlier in mind so that you know what to uh, put emphasis on. Okay. All right. Thank you very much. And I'll see you uh, in the next session.